Howdy and welcome back. So in this video, we're going to run through the first stage in the compilation pipeline, the preprocessor. We'll talk about some of the things that kind of go on and take a look at the output at this stage in the process. So to give you a kind of overview of the source code we'll be using for this process, let's go ahead and take a look here. I'm including two header files, other header file .h and utilities.h. My main function is going to do nothing interesting because we're not interested in the actual execution, creating an executable for this. Instead, we're simply interested in looking at the first stage of the compilation pipeline. Utilities.h is going to have an pound included by both .h header file, which we'll look at the contents here shortly. And it's going to have a declaration for a single function called square, which ultimately will be defined in the corresponding source file, utilities.cc, which we're simply going to take the input given as an integer value, square it, and return that result to the caller. Other header file is also included in our main.cc. It's going to also include this included by both .h, and it's going to have a single function declaration, boring function. I'm not providing a corresponding definition to this because it's unneeded at this point to illustrate what I'm hoping to. We're just looking at the preprocessor and we'll look at it on a single source file, main.cc. So we're not even going to bring in any extra source files into the compilation pipeline. We're going to look at just main.cc for now. And then when we hit the linker stage, we'll begin talking about, okay, well, hey, had there been a definition for this, its source file would have also had to go through the same process that main.cc would have gone through. And then at the end, they would have kind of collected at the linker stage. And then the linker would figure out, okay, well, where's the definition for boring.function? And then at that point, we might have an issue if it was called. But more on that soon. Here's included by both. Again, this is just for illustration purposes, and it has another boring function in it. Notice in none of these I haven't had include guards. The reason for that is I want to go through this just a couple times and then motivate the need as to why include guards are important. Then I'll go ahead and put them into these files to go ahead and actually resolve some of the issues that we see. So I'm going to hop down here and I'm going to simply compile through the preprocessor main.cc, and I'm going to store the output in preprocessor. And again, this is just for the main function. So what we're going to see here is the preprocessor is going to deal with these hashtags or ampersands, include statements, and any other hashtags and ampersands presenting throughout our source code. At this point in the semester, we're just going to talk about the include files and then also the kind of the conditionals that we're able to provide to the preprocessor as well to actually implement those include guards. So let's go ahead and execute this and look at what the output of this is. Okay, so we see a bunch of things kind of here, and then we see our first function declaration, another boring function. It's included by both. Notice that because it was included in two source files, both other header file as well as utilities.h, another boring functions declaration gets pulled into main.cc twice into this translation unit. That's okay. We can redeclare things as many times as we'd like, as long as these entities have a single definition for them. What we will see, however, is some of the problems as to what can present if we begin pulling in the contents of a specific header file multiple times. It can essentially create these very inflated translation units, which can cause the actual time to compilation to significantly slow, as well as other issues that can arise throughout this process. We can see here that in other header file, so it's essentially, okay, first one we've looked at, other header file, we've brought into it whatever's in this include by both. Okay, here's void, another boring function. Okay. And then our boring function, it's right there as well. And then if you notice here, okay, main.cc, looking in then at utilities, where we've pulled in the square as well as the declaration for another boring function, because again, utilities.h also pound included by both. So what you're essentially, and then here's our definition of main. So essentially what this pound include statement is doing is it's simply going out and it's pulling in, essentially performing a copy and paste, more or less, of the contents of the header files into this translation unit. What that means is in main, if we were to have square 11, let's just say it's stored in int I for lack of better. When main is going through the compilation stage, it will know what square is because it's been introduced. Its declaration has been included into this translation unit. Notice here, this is actually what's being fed into the compiler. So that's visible. It's just like we would have wrote it. It's just like if we copied and pasted it. However, this declaration is confined to one file. So why are the include statements helpful? Well, let's pop up here and go pound include IOStream. IOStream has a bunch of code that's going to get pulled in to this translation unit every single time that we essentially were to see it. So if utilities.h pound included IOStream, if other header file included IOStream, and there wasn't some way to prevent the file from being included multiple times, well, a lot of extra source code would be brought into this. And essentially we'd have to, the compiler would have to parse through all of that and make sense of it. And if if this starts adding up, you can see how big this translation unit can get and then the extra work that would go into it. So that's one reason which we'll see that pound includes will help us avoid. The other one that I want to illustrate to you is kind of fun. So the case that we just illustrated was, let me pop over, see if I can get onto this iPad. Okay, so we had essentially one source file, main.cc. It pounded included utilities. And that other one, whatever I had named it. And then we saw that both included this source file. Cool. So we essentially, without our include guards, we brought the contents into this file, into both the header files utility.h as well as, I believe, another header file. So, which was then brought into main. So this file essentially had its contents 2 times in main, given this structure. Okay, so that's one case where, and we just showed, if we pound include IOStream, how this could be problematic if a lot of extra things were being brought in. Well, sorry, I have a bunch of windows open. Where are you, code? Okay, let's say we had something like this. Let's say utilities.h pound included by both. And let's say that included.both pound included utilities.h. Okay, so I was wondering what the red line was, and the linter is kind of pointing out what is going to happen and why this is problematic. So I'm going to run the preprocessor. So what the heck's going on? Essentially, we created an infinite loop. If we go ahead and look at what happened back on the iPad, if I can find the window. Error. Oh no. Let me pause this for 1 second. Okay, sorry about that. I had closed the window here to my iPad. So just to sketch this out, we had main, pound include utilities. it also found, if I can draw here, this other file. And then what happened was this file included that file, and that file included this file. So it essentially went back and forth, and it kept trying to include one another. And essentially this was an infinite loop. So how do we avoid this? How do we ensure that each header file is brought into the translation unit exactly one time? Because if we bring it in exactly one time and we're going back and forth here, if we, by the time, okay, we include this, we go out, we get this. If we know when we execute this stage that we've already seen this file here, there's no reason to include it again because anything that's its contents are already in this translation unit. So this is where include guards come in. This is why every file, one of the reasons why every file is going to have them. So utilities.h, by convention, we're going to say if and def utilities underscore h, define utilities h, then and if at the end. So how this works, essentially the first line here is saying if utilities underscore h is not been defined yet. So if I haven't seen it, think about this as a conditional. So what's going to be executed is between the if and the end if. All of the contents between that block, if you will only be executed if utilities underscore h has not been defined. So if we haven't defined it yet, the first thing we're going to do is define it. And at this point, it's guaranteed that we've seen this file now once because we've defined utility.h. Therefore, anytime we were to attempt to include it again, this condition would already have been satisfied in the sense that it is defined. So we're not even going to bother getting into the actual contents that are associated with this if statement, with this preprocessor if statement. So, what that means is if we haven't seen it, we define it, and then that copy and paste process gets pulled into main.cc in this case. Okay, then when we jump over to, sorry, I was looking at the wrong file. Okay. So everything I just said has to do with utilities.h. Okay, now let's go do the same exact thing for the included by both. Sorry about that. So if and def included by both, and again, this is the conventional name. Go ahead and define it, and then end the if statement. Okay, and then we'll do the same by convention as adding in the include guards for it, other header file. So if not defined, other header file h, define it. Again, this like preprocessor variable. We'll go ahead and execute the pull in whatever's here down to the end. So again, this right here, that's the kind of conditional of this preprocessor if statement. This is where it terminates. So you can kind of think about this as being the opening curly brace, this being the closed curly brace. This is a preprocessor directive to define this variable. Therefore, the next time we come along and observe this, if we've already seen the file, other header file underscore h in this case has been defined, and therefore we will not pull in or execute anything within the body of the preprocessor conditional. So if we go ahead and execute this, we can see here now, running through, we're going to have one declaration of our square function. We're going to see here that we have exactly one definition or declaration, of our another boring function from this file that was included by both. So there are no longer two declarations of another boring function. And likewise, we have a single declaration of both boring and square, despite the fact that we had illustrated that circular relationship to kind of illustrate some of the motivations for having our header guards. And again, if you notice here, the contents of each of these header files was included in the main.cc translation unit precisely one time.